this video, you are going to learn the fundamentals of the two subjects, which are nothing but microprocessor and microcontroller. Okay. So these subjects are there for ECE branch and computers branch. So CS computers will have the subject called microprocessor, right? And ECE will have the microcontroller. For both the branches, either it is microprocessor or microcontroller, the fundamentals, the basics and the introduction to these topics, these subjects are same. So that's why this is a common video for both branches to understand the fundamentals of the microprocessor and microcontrollers. Okay, so that's what you are going to learn and understand in this video. So as I said, this is for microprocessors. We will have for branch computers. For computers branch. This is for ECE branch. For ECE branch. Okay. Now, what are the fundamentals? Let's discuss the introduction. Okay. So, as we know, a computer is a electronic device. A computer is a electronic device because computer is made up of all electronic components. So especially computers, you will learn a subject called computer hardware, in which you learn all the parts of the hardware parts of the computer. Now in this subject, you are learning the main and most important device that is present inside the computer, that is on the motherboard of a computer, which is nothing but microprocessor. And microcontroller is also same kind of IC, which is exceptional to the microprocessor. It will have different application. Okay? So we'll come to the division of these subjects in the next video, but this is the common for microprocessor and microcontrollers. Okay? So this is an electronic device. Here, microprocessor or microcontroller, both has the name which is nothing but micro. This is micro. What is the meaning of a micro? Micro is nothing but small. Okay? When we say microprocessor, it is small processor. Microcontroller is nothing but small controller. It doesn't mean that microprocessor, small processor means its capacity or its application is very limited. No, it is not like that. Microprocessor, small processor means its size is small. Its size is small. Okay, very small size ICs. IC is nothing but integrated circuit. So both microcontroller as well as microprocessor, they are small size ICs which are nothing but integrated circuits. Okay. Now one more technical reason why these are called micro, because these devices are manufactured using microtechnology. So what is a microtechnology? Microtechnology is nothing but VLSI technology. So VLSI technology is nothing but microtechnology. Microtechnology, because it's a microtechnology related, that's why these are called microprocessors and microcontrollers. Right? Now here, and these micro technologies are little earlier technologies. Nowadays we have nanotechnology, ultra technology. All these technologies have evolved. That means the size of the ICs in the computers, in the electronic gadgets everywhere, they are reducing its size. So that the technology is evolving from year to year. Earlier we have micro technology. Later it is evolved to nanotechnology, then evolved to ultra technology. But what is the microprocessors and microcontrollers that we are discussing in the subjects, which are very old ICs? They are manufactured. They are manufactured using microtechnology, and the technology name is VLSI technology. Now, what is VLSI? We'll discuss now. Now, VLSI technology, the full form of VLSI is very large scale integration, very large scale integration technology. Very large scale integration means integration is nothing but combining the so many components. Very large scale means so many number of components. Let's say you can say millions of transistors are used in single IC. Single IC. That technology is called VLSI technology. Okay? Right. Now here, as a basics to these subjects, which are nothing but microprocessor and the microcontrollers, the fundamentals you need to understand. That is from digital electronics subject. Okay? So in the digital electronics, you have learned a number system called hexadecimal number system. Hexadecimal number system, which will have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay, so I'll write the numbers here. Hexadecimal number systems, that is 0 to F, 0 to F, which is nothing but 0 to 15 in decimal number system. Okay, now what is after 15, right? So 15 is nothing but F. What is 16? This is after F, it should be, it is 0 F. F will roll off to 0. After 0 it is 1. Okay, 1 0, 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 1 7, 1 8, 1 9. After 1 9, it should be 1 A, 1 B, 1 C, 1 D, 1 E, 1 F. After 1 F, what is F? After F, it is 0. Okay, after F, it is 0. That means you all know numbers, decimal numbers and hexadecimal numbers in digital electronics. We have learned in the number system starter. After F, it is 0. After 1, it is 2 0. 2 0, 2 1, 2 2, so on, 2F. Okay, after 2F, it should be 3 0. Okay, 3 0 to 3F. After 3F, it is 4 0. 4 0 to 4F. After 4F, it is 5 0. 5 0 to 5F. Like that, after 5, 6 0, so on. At the end, you have F. The last one is F. So these are the hexadecimal numbers. If you take two numbers at a time, okay, 0F, that means the starting one is 0 0 to 0F, 1 0 to 1F, 1F to 2F, 3 0 to 3F, 4 0 to 4F, 5 0 to 5F. Like that, last one is F. FF. Last one is FF. Okay, so these are the hexadecimal numbers. And one more thing you need to understand about the powers of a 2. You need to learn them directly to understand the subject, that is microprocessor and microcontroller. Very easy. If you know the 2 power values, 2 power 0, 2 power 1, 2 power 2, 2 power 3, these values, if you understand directly, it becomes very easy to understand these subjects, that is microprocessor and microcontroller. Copies. As I said, you need to remember 2 powers. 2 power 0 is 1. 2 power 1. 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 6. 2 power 4 is 2 power 3 is 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. 2 power 7 is 128. 2 power 8 is 256. 2 power 9 is 512. 2 power 10 is 1024, which is approximately we call it as 1 kilobyte, 1K. This one is 1K simply. Next to 2 power 20, after 10, 2 power 20, 1 MB. This is 1 KB, this is 1 MB. 2 power 30 is 1 GB. 2 power 40 is 1 TB. So these are the values we have to remember. Okay. Now, as a subject is considered these subjects, microprocessor and microcontroller. The most important part of the processors and controllers is memory. Memory is very important. Now we discuss something about memory. Memories are nothing but RAM and ROM. RAM is nothing but random access memory, and ROM is nothing but read-only memory. Read-only. Now this is temporary memory. This is temporary memory. This is permanent memory. So these memories will be accessed by the microprocessor or microcontroller. For example, this is microprocessor or let's say this is microcontroller. These microprocessor or microcontroller will access the memory. That is RAM or ROM. Either RAM or ROM, it will be accessed by microprocessor or microcontroller. So to access the memories, that is RAM or ROM, we need to understand how these will be connected to the memory and how these are accessed. That means we need to understand the design part of the memory. Okay, so that we'll understand now. As I said, you need to remember two powers. 2 power 0 is 1. 2 power 1. 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 6. 2 power 4 is 2 power 3 is 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. 2 power 7 is 128. 2 power 8 is 256. 2 power 9 is 512. 2 power 10 is 1024, which is approximately we call it as 1 kilobyte, 1K. This is called as 1K simply. Next to 2 power 20, after 10, 2 power 20, 1 MB. This is 1 KB, this is 1 MB. 2 power 30 is 1 GB. 2 power 40 is 1 TB. So these are the values we have to remember. Okay. Now, as a subject is considered these subjects, microprocessor and microcontroller. The most important part of the processors and controllers is memory. Memory is very, very important. Now we'll discuss something about memory. Memories are nothing but RAM and ROM. RAM is nothing but random access memory, and ROM is nothing but read-only memory. Read-only. Now this is temporary memory. This is temporary memory. This is permanent memory. So these memories will be accessed by the microprocessor or microcontroller. For example, this is microprocessor or let's say this is microcontroller. These microprocessor or microcontroller will access the memory. That is RAM or ROM. Either RAM or ROM, it will be accessed by microprocessor or microcontroller. So to access the memories, that is RAM or ROM, we need to understand how these will be connected to the memory and how these are accessed. That means we need to understand the design part of the memory. Okay, so that we'll understand now. So any memory, let's say, as we have seen, either RAM or ROM, any memory you take, so the design part will be like this. Okay, this is memory. This is a memory. Now this block is called memory cell. This is called a memory cell, right? So every memory cell will have 8 bits. Every cell will have 8 bits. How many? 8 bits. Right? I'll write that. Every memory cell can hold 8 bits. Can hold 8 bits. Right? Now this one will have address 0, address 1, address 2, so on, address n. Okay, this is one more important. Every memory cell will have an address. Will have an address. Using this address only, using this address only, microprocessor or microcontroller will access the memories. Will access the memories. That means, for example, a postman want to hand over the letter to any particular house. Now, how does the postman knows that that letter belongs to some house? That is by the address that is mentioned on the letter. So, what does the postman will do? The postman will look at the address. First of all, he will look at the pin code to which area it belongs to. Then he will look at the locality, then colony. Then he will go to house number. So this is the procedure followed by a postman to reach a particular house to hand over the letter. That is a very simple thing everyone will do. That means to deliver any letter, courier, anything, the most important thing here is address. Address is a very important. Similarly, microprocessor and microcontroller, they are connected to memories external. Okay, for example, this is microprocessor, this is external memory. Memory is connected to the microprocessor, microcontroller externally using wires, conductors, and in particular, technically we call it as a bus. Okay, it is connected to the memory by a bus. When it is connected, how does microprocessor or microcontroller knows that a particular memory location? For example, microcontroller, microprocessor has a data, a bits, group of bits are there that need to be transferred to the memory. How does these knows that to which location they have to transfer? They doesn't know. Okay, so that's why what they do, they will send the data to a particular address. If they are given with address, then it is easy to transfer the data. So address of memory location is very important. Now what is the relation? Relation between address and memory. Address and memory. So here memory is equal to 2 power number of address lines. This is the formula. Memory is equal to 2 power number of address lines. For example, n is equal to 4. Now what is memory? 2 power 4, which is nothing but 2 power 4 is 16. So 16 bytes. Okay. For example, n is equal to 12. Now n is equal to 2 power 12. 2 power 12 can be written as 2 power 10 into 2 square. 10 plus 2, 12. 2 square is nothing but 4. 2 power 10 is nothing but kb. That's how I said. So it is 4 kb. So what is the memory here? 4 kb if n is equal to 12. So this is the way of calculating the memory when you have number of addresses. For example, n is equal to 12, n is equal to 16, n is equal to 7. These are the examples I have taken. So we know m is equal to 2 power n is a formula. So memory is equal to 2 power 12. As I said, I can convert it to 2 square into 2 power 10. 2 square is nothing but 4. 2 power 10 is nothing but kb. So memory is equal to 4 kb. Similarly, memory is equal to 2 power 16. Okay, so I can write 2 power 6 into 2 power 10, which is nothing but 2 power 6 is nothing but 64. 2 power 10 is nothing but kb. So memory is equal to 64 kb. For example, n is equal to 7. So m is equal to 2 power 7. So 2 power 7 means 128 bytes. 128 bytes. Now I want to know the address range of these one. For example, how to calculate address range? Address range. So address range is nothing but, for example, n is equal to 12. Now I have to write 12 zeros here. Convert into hexadecimal. This is 12 zeros, I write 12 ones. Divided. This is 0, 0, 0. This is F, F, F. Now the answer is 0, 0, 0, H2, F, 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 H. That means, for example, I have a memory. If n is equal to 12, n is equal to 12 means what? N is equal to 12 means 4 kb. Okay? So this is 4 kb, 4 kb memory. And the starting address range is 0, 0, 0, 0, 0, 0, 0, 0, 0, H. Up to the final address is F, 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 H. So this is the range of addresses. It will lie between 0, 0, 0 to F, F, F. So this is the address range of 4 kb memory. It could be RAM or ROM, anything. So this is the way of calculating the memory size, and address range. So this is the procedure. Okay, one more example. See, let's say n is equal to 7. How to calculate address range? Here, 7 means 7 zeros right away. Only 7 ones. Okay, divided by 4. I will append one more 0 here. 0, 0 is nothing but 0, 0, H. 0, triple 1 means 7. 4 ones means F. Okay, so what is the address range here? 128 bytes of memory. 128 bytes of memory will have address from 00H to 7FH. Okay, so this is the way of, this is the example 2 I have. So this is the way of calculating the address range if memory size is known or number of address lines are known. Okay, so these are the very much important fundamentals both for microprocessor subject and microcontroller subject. Okay, so in the next upcoming video, you will understand separately what is the architecture of a microprocessor, what are the programs related to microprocessor, okay, and pin diagram of the microprocessor, okay, and other than they will learn what is the architecture of microcontroller, pin diagram, next instructions, okay, programs. All these things you will learn separately about the microprocessor as well as about the microcontroller. Okay, so these are important fundamentals you need to understand, right? Then only you can understand the upcoming topics that are there in these subjects. Okay, so hope you all understand the basics, fundamentals related to memory, address range, and microprocessor, microcontroller device, VLSI technology, all these things. Thank you.